Moving on in Unit 2, continuing with linear functions, we're going to get into slope and rate of change. Okay, in 2.7 we had covered intercepts and interpreting intercepts, so now we're going to get into slope and interpreting rate of change in application problems. So slope really just measures steepness of a line and direction of a line, right? So steep basically refers to how fast it rises compared to how fast it runs, right? Meaning how far it goes up compared to how far it goes across. And also direction, right? Whether it goes up or down from left to right, right? And that's something that we're going to get into as being important. When you determine whether a slope is positive or negative, you're always going to be looking from left to right. And then a horizontal line is actually not going to rise or fall, right? It's just going to go straight across, right? It's just going to run, so that's going to have a slope of 0. So what do we think here? So in the first graph on the left, right, that's falling from left to right, so that's actually going to have a negative slope. B is horizontal, it's neither rising nor falling, therefore it's going to have a 0 slope. And then the one on the right, that's rising from left to right, therefore that's going to have a positive slope. So if it's falling, it's negative, if it's rising, it's positive, and if it's flat, right, if it's horizontal, it's 0, no change. So in this case, we're trying to determine which graph has a steeper slope, right? They're both positive, but which one is steeper? So in other words, which one rises faster, right? So the one on the left actually rises much faster than the one on the right does. And then in the case of 3 there, they both are negative slopes, so which one has a steeper negative slope? In other words, which one falls faster, right? So graph B actually falls faster. So graph B is going to have a steeper negative slope. So in the case of these exercises, 1A, right, is horizontal. It's neither rising nor falling, therefore that's going to have a slope of 0. 1B is falling, that's going to have a negative slope. And now we determine in number 2 which one is steeper. So 1 is positive, 1 is negative. So which one is steeper? In other words, does this rise faster than this falls? No, actually, this falls faster than this rises. So this one is actually going to be steeper, right? When you're talking about steepness, direction doesn't necessarily matter. This one is falling faster than this one is rising. So this one is actually going to be steeper, right? This one has a 0 slope, and this one had a negative slope. So how would you find the slope from a graph? Very easy. What you got to do is you got to find 2 nice points, okay? So in the case of this graph here, the nice points, right, that they're calling integer points could be 0, 1, and 2, 1.5. Begin at a point on the left, in other words, a 0, 1, and then see how far up or down and across you have to go to get from the one point to another. So in this case, I actually had to go up 1 unit, which actually was really a half of a unit. It's really going up 1/2. And I actually had to go over 2. So in this case, my slope is really not 1 over 2, but 1/2 over 2, which is really 1/2 times, right? Remember, it's keep, change, flip. So you do 1 divided by 2 is really, oh, sorry, 1/2 divided by 2 is really 1/2 times. You flip 2 and you get 1/2. So in this case, it's actually 1/4 because I went up a half only and over 2. Right? So the slope in this case was actually 1/4. So that kind of illustrates that you had to be aware of what the scale is on both the axes, right? Because in this case, even though you were going up 1 box, it was really only a half a unit. And then in this case, similar thing, you can't really worry about the scale on the y-axis because the scale on the y-axis is actually a half again. So in this case, if you're trying to find the slope that connects the point 0, 1 with the point 1, 6, what do you have to do? You got to see how far you're going up, which is from 1 to 6, I went up 5, and from 0 to 1, I went over 1. So in this case, the slope is 5 over 1, right? Because I went up 5 and over 1. And then in the case of this one, I'm connecting the point 0, 1 with the point 10, 0, right? This is only one box, but it's really 10 because the scale here is 10. So when I go from this point to this point, yes, I'm only going down 1, which is a negative 1. But here I'm going over 10. So the slope here is going to be rise, which is really a fall of 1. So negative 1 over 10. So in that case, the slope is negative 1/10. So what's the formula for the slope of a line if you don't want to just count boxes? The formula, if you're thinking about 2 points that you're going to call x1, y1 and x2, y2, is really just y2 minus y1, because this is really the change in the y over the x2 minus the x1, which is really the change in x, right? And that little symbol there, delta, that basically means change, okay? And how do you find the change? You subtract, right? Which is really finding a difference. And then the slope is always going to be represented by that little letter m, right? Little m stands for slope. So the slope can be defined as the rise over the run, or the change in the y over the change in the x, which can be written as the delta y over the delta x, which if you have 2 points, you can think of as y2 minus y1 over x2 minus x1. So these are all really equivalent ways of thinking about slope, depending on whether you have a graph, you think of rise over run. If you have 2 points, you think of doing y2 minus y1 over x2 minus x1, right? And when do you use the delta y over the delta x? Usually when you have I think of this when I have a table. When I have a table of values, I usually think about using change in y over change in x. So in this case, what's the slope of these lines that go through these points? Well, here you would just realize, hey, this is x1, y1, x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1. So it's going to be 2 minus 8 over 2 minus negative 10. 2 minus 8 is negative 6. 2 minus negative 10 really becomes plus, so it's 12. So 6/12 is 1/2. And then in the case of this one, again, you think of this as x1, y1, and this is x2, y2. So the slope is going to be 3 minus negative 3 over negative 4 minus negative 10. And this is going to become 6, right? And this is going to be negative 4 plus 10, which is 6. So this is really going to be 1. So the slope of that line is 1 over 1, or just 1. And we had said already before that the slope of a horizontal line is going to be 0. So if we have these points, negative 8, 3 and 2, 3, and again, you're using your slope formula, in this case, the two y's are the same. So when you do y2 minus y1, you're going to get a 0 in the numerator. So it's 0 over 10, but 0 over 10 is just 0, right? So that's going to be a horizontal line. But then when we have this, now look what happens. Now the y's change, so the slope would be -3 minus 3, but the x's are the same. So -2 minus -2, that's actually going to be -6 over 0, which is something that we had called undefined. So in this case, we have an undefined slope, and that's actually going to be a vertical line. So just remember, rising line, positive slope. Falling line, negative slope. Horizontal line, zero slope. And a vertical line, undefined slope or no slope. I like to say undefined rather than no because a lot of times you associate no with being zero and it's different, right? So usually I wouldn't think of this as no slope, but I would think of this as undefined slope. And if you remember, a vertical line is actually not a function, because remember when we did functions we talked about vertical line test. So a vertical line is not even a function. So just keep that in mind. So that would be a horizontal line. That would be a vertical line. And then they just use this little Mr. Slope guy we're saying. Positive slope, up. Negative slope, down. Vertical line, undefined slope. Horizontal line, zero slope. And then we can practice some of these in a separate example.